Good morning, good afternoon, and good evening to everyone joining us from different parts of the world. A very warm welcome to day two of the fifth International Conference on Universal Threats in Expert Applications and Solutions, or as we fondly call it, UNI-TEAS 2026. I am Shambhavi Tomar, and it's an absolute pleasure to moderate today's online session. This prestigious conference is being organized by Shree KKarni Universe College, Apex University, and Panipat Institute of Engineering and Technology, managed by KK Consultancy Services India and supported by the University of Rajasthan, ACM Jaipur Chapter, All India Council for Technical Education, and Computer Society of India Jaipur Chapter. This year, we received an overwhelming response with over 300 paper submissions from across the globe. After filtering out AI generated and plagiarized content and a rigorous peer review process by our expert panel, only the top 80 papers were selected for presentation. Based on their performance and the recommendations of our session chairs, these selected papers will be published by Springer Nature. The first half of the day one of the conference, that is 16th of February 2026, we had an incredible series of keynotes, paper presentations, award ceremony, and discussions that truly embodied the spirit of innovation and inclusivity offline in Jaipur. As we step into the latter half of the day two, we carry forward that same enthusiasm, ready to dive deeper into thought provoking sessions and interactive presentations that will continue to shape the future of intelligent systems and digital security. With that, I am pleased to introduce our session chairs for this segment. So we have Shilpi Yadav ma'am, who is a technical solution architect at IBM, North Carolina, United States. Second up, we have Darshanaben D. Pandya ma'am, who is an associate professor at Sankalchand Patel University, Gujarat.
Okay, thank
Then,
you.
yes ma'am. Then we have Chandresh K. Kumbharana sir, who is a professor at Saurashtra University, Rajkot, Gujarat. Okay. So before we proceed further, I would like to share a few important instructions for all the paper presenters to ensure a smooth and timely session. First, each presenter has 10 minutes to present. So I would request you all to please adhere to the time limit. Second, briefly cover your research context, objectives, methodology, key findings, and conclusion. Third, a short Q&A may follow your talk of 1 to 2 minutes. Keep responses brief and focused. Fourth, keep your mic muted when not speaking. And last, stay for the full session to support the fellow presenters. With the kind permission of our session chairs, we shall now proceed with the paper presentations. Um, can we?
Yes, ma'am.
Thank you, ma'am.
Continue.
So I would like to invite our first presenter for the day, Anju Bhandari Gandhi, whose paper is titled Identification and Ranking of Barriers to Industry 5.0 Adoptions in the Indian Manufacturing Industry, a Fuzzy Topsys Approach.
Namaskar, madam.
Namaskar, sir.
Myself, Professor Kumbharana.
Yes, sir.
Okay.
Sir,
I
now
wish
we are
all the
beginning
best.
with the.
I wish all the best to all the participants, and you may proceed for the presentation.
Okay, thank you, sir.
Thank you.
Okay, so this first presenter's paper is titled. Um, it's under the paper ID 419. So I would now request them to take the virtual stage and begin with their presentation. Do we have Anju Bhandari Gandhi with us? I think she has not joined the link till now. Okay, so let's take up the second paper. Kong Doan Truong and their team, the participants I can see on the screen, Thi Lich Nigihem, um, Thi Nang Din, and yeah, okay. So their paper is titled Improving Carbon Emission Reduction Transparency Using Machine Learning and Explainable AI Techniques under the paper ID 420. I would request them to begin with their presentation.
Namaste, madam. Voice is not coming. Hello.
Hello.
Voice is not coming.
Yes, sir, they have just now started presenting.
Okay, okay, no problem.
Hi everyone. Mm, Good afternoon, Sankalchand, ladies and gentlemen. Welcome to our presentation at the 5th International Conference on Unity 2026. My name is Nhung and I am delighted to represent my research team from Thương Mại University and Vietnam National University. Today, I will present our paper titled Improving Carbon Emission Reduction Transparency Using Machine Learning and Explainable AI Technique. Uh, to guide you to next slide that to guide you to our research today, I will start by introducing the research context and the problem statement we are addressing. Following that, I will detail our methodological framework, including how we process our data and develop our models. Then I will present the experimental result along with our uh, comprehensive analysis using explainable AI. Finally, I will wrap up the presentation with our conclusion and outline potential direction for future work. Let's begin with introduction. Climate change and CO2 emission have evolved into urgent global challenges that impact every sector of the economy. The logistics sector is facing increasing pressure to adopt sustainability practice and reduce its carbon footprint. Blockchain technology is emerging as a powerful solution to enhance traceability and data transparency. Artificial intelligence and machine learning enable emission monitoring and prediction. Despite the technological advance, current approach still suffer from significant limitation. Traditional approach rely on qualitative risk measure and reactive alerts. The core problem is a lack of explainability which reduce stakeholder trust. Therefore, we propose in an integrated blockchain machine learning exercise framework. The primary goal is to develop an integrated machine learning exercise framework to predict CO2 emission reduction. We evaluate random forest gradient putting trees and attribute our assessment focus on accuracy and interpretability. Our paper offers two main contributions to the fight. We provide a rigorous comparison of three machine learning models using real-world data. Explain AI transform predictions into understand insights. Now move the methodological framework of Figure 1. Next slide that. Next, next, next. Figure 1 illustrates our proposed framework. The process including pre-processing, modeling, training, testing, and evaluation. Performance is evaluated using RMSE and MAE. We apply sharp and line for interpretability analysis. Mm, in this point, I I would like to invite my team to continue with the experiment result. Ian.
Hi, my name is Hai Yin, and now I will continue our presentation about experimental results. In this part, we will show how the model performed and what insight we found from the data. To begin with, we use a dataset from cargo related to supply chain logistics. It includes important features such as industry type, company size, and blockchain adoption years. Our target variable is the percentage of emission reduction. Before training the model, we clean and prepare the data to ensure accuracy and consistency. To evaluate the model, we use two command metrics, RMSE and MAE. Simply put, the lower value, the better model performs. These metrics help us compare to prediction accuracies of different models in a clear way. And now let's look at the overall performance. As shown in Table 1, random forest achieved the best result, with the lowest MAE and RMSE. Compared to GBT and HGB, random forest was more stable and accurate. Therefore, we selected random forest as the best model for our dataset. Next slide, please. Next. Okay. So we analyze model performance across different industry. The technique sector has the lowest error, followed by retail and manufacturing. This means their emission patterns are more stable and easier to predict. In contrast, agriculture has the highest error. This is understandable because agriculture's needs depend heavily on weather and seasonal factor. For logistics, which is our main focus, this error level was moderate. This makes sense because logistic operation depend on fuel prices and routing complexity. So overall, the model worked well for most industry, but sector with high uncertainty may need more specific data. Besides accuracy, we also wanted to understand why the prediction we use in soft analysis. We found that course, blockchain carbon dioxide emission is the most important factor. Lower emissions strongly improve the prediction score, and blockchain integration is the second most important variable. This shows that need for blockchain adoption support sustainability performance. Operational factors like automation and cost saving also play a key role. So interestingly, company size or local location has very little impact. It means how a company operates is more important than how big is it. Y-Sub through the overall Python line expand individual case. And this example model predict 28.1 with 0.01 which very close to the actual value of 29.9.18. The strongest negative factors were the post-blockchain carbon dioxide emission. However, these were balanced by positive factors like cost saving and automation improvement. This shows that operational improvements can significantly increase emission reduction performance.
Sorry to interrupt, but you just have 1 minute left, so please wrap up.
Okay, thank you. Finally, I will summarize our key findings and suggest future research direction. To summarize, first, machine learning and XAI provide reliable and transformation emission for reduction. Secondly, random forests were the most effective model, and most importantly, operational improvements directly drive emission reduction. So for the future research, we plan to add time series and environmental data, explore deep learning models, and improve interpretability techniques to increase user trust. So that's all I want to talk to you about our presentation. Thank you for your attention. I'm happy to answer any questions. Thank you.
Thank you so much, both of you. Now we are open to any questions from the audience or the session chairs.
Hi, thanks for the presentation. It was pretty good. Just a quick question. You mentioned about Kaggle dataset. Did you use all synthetic one, or did you also try to use some real-time data in picture, like when you were creating your experimental setup?
Okay, so now let's move on to the next presentation. If there are no further questions and no answers. Okay, so we have Truong Kong Duan, who is going to present the paper titled Applying Machine Learning Algorithms to Stock Price Forecasting and Causal Analysis of ESG Effects on Returns under the paper ID 424. Over to you.
I'm here. I'm a member of group research of Truong Kong Duan, and now
Okay.
I will present our research. Wait me a minute. Can you wait? Can you see my screen?
Yes, you may begin, and you only have 10 minutes.
Thank you. Good afternoon, everyone. I'm Ha Chan, and today I will present our research applying machine learning algorithm to supply forecasting and causal analysis of ESG effect on return. And our study investigate two main questions. First, can ESG information improve supply forecasting using machine learning? And second, does ESG have a real causal impact on firm returns. Next, and about our motivation. In recent years, ESG have evolved from a voluntary corporate responsibility practice into an important factor in investment decision. And with the growing of global concerns such as climate change, government issue, social inequality, ESG is now considered a tool for reducing risk and supporting long-term value creation. However, most previous studies have three main gaps. First, they do not evaluate ESG within a machine learning framework. Second, they suffer from methodological limitations. And finally, there is no unified ESG standard. Therefore, our research aims to address this limitation. About our key contribute, first we evaluate the multiple machine learning model for ESG integrated supply forecasting. Second, we compare the predictive power of each ESG pillar. And third, we apply causal inference using double machine learning to examine the impact of ESG on both monthly and annual returns. And finally, to SAP analysis, we identify the ESG role in forecasting. And here is our highlight. Our process include data preprocessing, feature selection, model training, and evaluate, sub-interpretation, and causal inference analysis. And our data sets about the dataset, our dataset consists over 296,000 firm day observation, covering covering 303 publicly listed companies from February 2019 to December 2022. And we collected the stock price and finance indicator from Yahoo Finance, and ESG score and ESG risk score from the couple. And we split the data into 80% training, 10% validation, and 10% testing with the time ordering. And about the model, we test 5 model: linear regression, rigor regression, random forest, gradient boosting, and equal with the linear regression and rigor regression serve a bandmate model due to interpretability and stability. And a tree by example model like random forest and boosting to capture the non-linear relationship. And about the model evaluation, we use mean absolute error, mean square error, and R square. And here is a detailed formula to calculate the sub value. And here the detailed theory about the linear double machine learning, which we use to analyze the causal inference. And here is our result. First, about the model performance, and we see that the linear regression and rigor regression perform best, and random forest and gradient boosting perform slightly worse, while the equal perform the worst in this dataset. This suggests that the surprise in our dataset follow strong linear pattern, and a complex model may introduce unnecessary noise. About the SAP evaluation, um, in this we can see that the most important feature are ladder clothing price and moving average. In this case, MA7, moving average 7. The ESG variable contribute a little to short-term daily price forecasting. So that means the daily price movements are driven mainly by uh, tech, technical indicator, not ESG characteristic. And about the causal inference analysis, we find that in this part we find that although ESG is weak in short-term forecasting, but in the long-term tell a different story. We find that higher ESG score leads to higher firm returns. Government has stronger short-term effects on the monthly return, and social risk and I'm sorry, environment and social factor have a stronger long-term effect on the annual returns. About the yearly ESG risk, environmental risk, so positive association with profitability, while social risks have a negative effect on returns, and the government risk had low significant impact. So that confirm ESG matters in long-term perform of the stock of a firm. And here to summarize the discussion, first we can see that Nanya and regression model are the best in our data sets, and complex model like rainforest or eagle may make a noise in this model, so it makes the perform less not better than this than 90 and rigor. About the SAP value, ESG profile limited predictive value, and in the causal inference, ESG positively influence in on the long-term return of a firm. So ESG may not predict daily price fluctuation, but it play a meaningful role in long-term investment performance. And here are some limit. First is ESG indicator are not effective for daily forecasting, and complex model like Eagle are less stable in our research. And in the future, we plan to explain our ESG datasets to close with the time, close with this time, and shift the focus from predict price to return and risk in the long term. And here is our inclusion. We can summarize that ESG does not significantly improve on short-term stock price prediction. However, ESG had a clear and positive causal impact on long-term return. So therefore, ESG should be viewed as long-term value driven rather than short-term trading signal. And that's the end of our presentation. Thank you for your attention.
Thank you so much. We can take up any questions if you.
Pretty
Yes,
good
ma'am, please.
presentation. I would just like to mention it is pretty good covered.
Okay, ma'am. Thank you. Okay, so now let's invite our next presenter, Pratibha Shukroop, who is going to present a paper titled Trustworthy AI for Cardiac Healthcare, a blockchain-based architecture for secure data sharing and clinical analytics. Over to you.
Yes, ma'am, I'm sharing.
Ma'am, you only have 10 minutes to present.
Yes, ma'am.
Hai buồn thành công rồi anh em.
Then my PPT is visible.
Yes. Yes, it's visible.
Okay, ma'am. Good afternoon, respected chairperson, distinguished researchers, and fellow participants. I'm pleased to present our research work titled Trustworthy AI for Cardiac Healthcare, a blockchain-based architecture for secure data sharing and clinical analytics. This work focuses on developing a secure, privacy-preserving, and clinically interpretable AI ecosystem specifically designed for cardiac healthcare. In this presentation, I'll begin with the motivation and the problem statement. After that, I will explain a proposed framework, system architecture, and methodology. Finally, I will present experimental results, clinical usability findings, challenges, future discussions, and conclusion directions. Now, my background is cardiovascular disease remains the leading cause of mortality worldwide, responsible for approximately 18 million deaths annually. This highlights the urgent need for early diagnosis, continuous real-time monitoring, personalized treatment strategies. With the rise of AI-based ECG analytics, wearable IoT devices, and cloud health platforms, cardiac diagnosis has become the more data-driven. However, as a healthcare become digital, concerns regarding data privacy, security, and trust become critical. Therefore, building trustworthy AI system is essential for future cardiac care. Problem statement. Despite technological advancement, traditional AI-based cardiac system face serious limitation. First, centralized storage systems are vulnerable to data breaches and single point of failure. Second, AI models often function as black boxes, providing predictions without explaining how they were derived. These Third, these systems are vulnerable to data tampering and data positioning attacks. Finally, patient privacy is not adequately preserved. In high-stakes medical environments, such vulnerabilities cannot be ignored. Hence, there is a need to secure transparent and trustworthy AI framework. To address these challenges, we proposed a blockchain-enabled trustworthy AI framework. Our framework integrates four key components. First, blockchain for tamper-proof data storage. Second, federated learning for privacy preserving and collaborating training. Third, advanced AI models for accurate cardiac analytics. Fourth, explainable AI to ensure interpretability and transparency. This integrated design ensures both technical robustness and clinical reliabilities. Overall system architecture. This system has a five-layer structure: data acquisition layer, blockchain layer, federated AI layer, explainable AI layer, and application layer. Each layer is designed to enhance security, privacy, collaboration, and clinical usability. This modular structure ensures scalability and adaptability in a real-world healthcare system. This diagram visually represents the interactions among all five layers. Data flows securely from acquisition sources into blockchain validation, then into federated AI training, followed by explainable interpretation, and finally into clinical applications. The layer design ensures security at every stage of the pipeline. Now, data equalization layer. This layer collects cardiac data from multiple sources: ECG sensors, smartwatches, monitoring HRV and SpO2, hospital health records, lab biomarkers, cloud-based imaging system. All data is encrypted before transmission. This guarantees privacy protection at the source level. Blockchain layer. The blockchain layer ensures immutability and auditability. We use SHA-256 hashing to secure transactions, smart contracts for access controls, PBFT consensus mechanism for validations, public-private key cryptography for identity management. Platforms such as Hyperledger, Fabric, and private networks are used. The result is a fully tamper-proof and transparent audit trails. Next, federated AI layer. The federated AI allows multiple hospitals to collaboratively train models without sharing raw patient data. Each institution trains its local model. Only encrypted gradient updates are shared and validated on the blockchain. A global model is aggregated while maintaining privacy. This approach enhances generalization and preserves confidentiality. Explainable AI layer. To build clinical trust, we integrated explainable AI tool. SHAP share values, highlights feature importance, creates CAM, visualizes important ECG reasons, rule-based surrogate models simplify prediction. This ensures that clinicals understands AI reasoning before making decisions. Interpretability significantly improves adoption in real-world practice. Methodology. Our methodology consists of 5 key steps. First, ECG pre-processing with Butterworth filtering, using Butterworth filtering. Second, blockchain hashing and transaction validation. Third, AI model development. Fourth, federated learning aggregation. Sixth, XAI-based explanation generation. This pipeline ensures security, accuracy, and integrity at the every stage. This figure shows a complete workflow from signal processing to explainable output. It demonstrates how blockchain, federated learning, and AI models interact systematically. Model performance results. A result demonstrates significant improvement. The traditional CNN LSTM model achieved 92.5% accuracy, 0.091 FI score, 0.93 AUC. Our proposed integrated work achieved 96.8% accuracy, 0.95 FI score, and 0.97 AUC. This indicates improved diagnostic precision and reduced false predictions. Blockchain performance. Although blockchain induces a slight latency increases from 320 microseconds to milliseconds to 350 milliseconds, but this change is acceptable in medical system. However, the gain in data integrity and trust is sustainable. The system achieves near 100% tamper-proof reliability. Thus, the security benefits outweigh the minor latency increases. Our challenges and future work. Despite its advantages, the system faces challenges. First, blockchain scalability in large hospital networks. Second, computational overhead of federated learning. Third, interpretability among heterogeneous hospital system. Fourth, need for clinical training in interpret AI explanation. Addressing these challenges is essential for large-scale adoption. Our future work. Future work will focus on quantum-resistant cryptography, 5G-enabled edge processing for real monitoring, development of cardiac digital twins, energy-efficient blockchain mechanism, large-scale multi-hospital clinical trials. These advancements will enhance performance and the real-world acceptability. Now, conclusion. In conclusion, our blockchain-enabled trustworthy AI framework, it enhances diagnostic accuracy, ensures data integrity, preserves patients' privacy, improves clinical transparency. By integrating blockchain, federated learning, and explainable AI, we establish a secure and ethical ecosystem for next generation and cardiac healthcare. Thank you. I welcome your question and feedback.
Thank you so much
Thanks,
for your.
Pratibha. Yeah,
Thank you.
just a quick question, if you may allow, Shambhavi.
Yes, ma'am, please.
Yeah, it's a pretty good presentation, Pratibha. What I could not understand is what kind of result you were targeting. Were you only targeting the qualitative result, or did you do some quantitative tool? Because I could not see that comparison.
Ma'am, actually, we're mostly focused on the increasing latency. There's 320 milliseconds to approximately 350 seconds milliseconds in our experiments. However, this delays remains with unacceptable medical thresholds. But the gain in tamper-proof integrity overweight the minor performance. And the second most important, we focus on the patient's privacy. That's the main concern.
Yeah, that is the most, because it's one of the sensitive data. Okay, thanks.
Yes, ma'am.
Okay, so now I would like to call our next presenter, Palem Narasimhulu, who is going to present the paper titled Edge Intelligent Underwater Image Enhancement for Hyperconnected IoT-based Ocean Monitoring Systems under the paper ID 426. Over to you.
Thank you. It is, sorry. Yeah. Okay. Today, my paper is Edge Intelligent Underwater Image Enhancement for the Hyperconnected IoT-based ocean monitoring system. See here, generally we can go for the base outline. What is the introduction of the underwater image? What is the problem statement? The next, we can consider what is the motivation of that. The next, I can go ahead the objectives of research work. The next related work, what is the gap analysis? Then you can go, we can proceed. What is the framework I used here? The next experimental setup. Here I can discuss about the data set. The next, what are the metrics we used? Those kind of things. The next here, result analysis. I used quantitative and qualitative analysis. Then later we can discuss about the things. The next application study. The next conclusion. The extension scope of work. That is the feature work. Then finally we can go for references. Now here generally underwater image always suffered from the color distortion. The next contrast, that is a contrast loss. You can consider as a low contrast. The next blurred image details of the underwater image. The next haze. The next scattering. We come to know what is the scattering. The scattering, the light scattering is a process where the light rays change the direction after hitting the water particles. The next the poor visibility of the image, the blurriness, as I said, right? Those kind of things. The next, what is the motivation of this one? The mainly we can focus on monitoring. Underwater monitoring plays a vital role. That is like a marine ecosystem. The next inspection, that is oil and gas inspection. The next defense surveillance. Next you can go for underwater vehicles and remotely 1 minute remotely. The next, sorry, remotely operated vehicles. Remotely operated vehicles. Here, what is the difference between these two means? Underwater means autonomous underwater vehicles. Autonomous underwater vehicles are robotic systems operating independently without human control, whereas the remotely operated vehicles are means mandatory with the human control is required. It is like the underwater robots that operate with human intervention. The next to marine operations. Next, why do underwater image degrade? So here, just the wavelength, the depth, that may be, suppose if we have the image, the next, the red light disappear quickly. Whenever the focus will come directly in depth wise, the red light will be disappear. The next, blue-green penetrate deeper. The next, color imbalance. Light scattering means light scattering, as I said, right? We have differentiation backward scattering, the next forward scattering. Backward scattering means whenever the light come from the object, the light reflect back to the camera. That you can consider as a back scattering. We will see in the future, the next slide, the produce the hazy, red is the constant, the next blurriness of the underwater images. Now, see here, the red wavelength. Whenever in-depth will come, then the color will be changed. This is for absorption with depth. See, back scattering. When you feel back scattering, I said, right? The light is reflected back to the camera. What is the forward scattering? Forward scattering means it is like the light is scattered in the forward direction towards to the object before hitting the camera. That is the main intention. Based on these details, then you will get the result as a low contrast and reduce the visibility. Now, here also I have specified the color changes, low contrast, the next scattering of that one. Whenever you will use the cameras, underwater cameras, the next moderate turbidity and high turbidity. The next introduction. In this introduction, just I can say, like, we have some traditional methods and also deep learning methods. Then how traditional methods are there, what are the things we'll do, then what is the limitation of in this one. Whenever you will use, like, white space, white balance and histogram equalization and then gamma correction, these are the best, but these are the best and fast, but lack of adaptability. When it comes to the deep learning methods, here we can use CNN, GAN, and then transformer based methods. Here we will get better restoration, but those things are very heavy and not suitable for edge IoT framework. And also here we are not using any hybrid real-time framework. These are the drawbacks of limitation of the traditional and then deep learning approaches. The next two, when you go for the proposed framework, as I said, right, IoT, hyper-connected IoT monitoring, like marine monitoring, right? Here we can specify, like, this is the approach framework we can assume. Here we have 3 layers. This is the first layer, that is underwater sensing layer. This is the middle layer, that is the edge intelligence. The next, the top one will be a cloud intelligence. See here, the raw image will be here. We need to take the capture of the raw image, and then what we are doing here, just we are transmitting to the edge processing unit. From here onwards, then we can send to the there is a bidirectional communication between the top layer and the middle layer. Then here we can, like, the edge send the enhanced images to the top layer. That is alerts kind of things. The next, the cloud is also sent update down to the edge. That is the one only difference. The next, research objective. The research objective means generally we need to compare the underwater image techniques. This is a state of the art. We can consider this one as a. So here we are using traditional methods and then learning based methods. Here we can integrate the traditional and then deep learning based methods for improving the stability and then performance. And also we used and developed the lightweighted real-time model. This is for real-time deployment only. The next, when it comes to the domain adaptation, we need to ensure like the performance across the underwater environment. Then you can go for compare with the existing techniques like a quantitative and then qualitative analysis of it. The next, the related work, as I said, right, we have traditional methods like the retinix based correction and also white balance. The next, histogram equalization and then gamma correction. Whatever the raw image we are taking, this image we are sending to the 3 stages. One is traditional enhancement, the next deep learning based model, the next hybrid edge intelligence enhancement. Here, whenever we are using these many models, then we have like some gaps, that is ignore the real-time constraints. The next, we are ignoring the IoT deployment and also domain shift between the data types. That is also we are ignoring. These and all we can consider as our gaps to address these gaps. Now, the traditional methods are very fast, but limited robustness. The next, deep learning method will use the better quality, but computationally heavy. The next, these approaches will give the image enhancement. The next will go for final where 2 research gaps. One is domain adaptation, that is across different underwater environments, is rarely addressed. Here we don't have any IoT edge, cloud, collaboration. These things we need to add in this framework. Now,
Sir, please be quick. You have just 1 minute left.
yeah, please. The next here, the proposed framework. Here we are using like raw image to the particular edge processing unit. We have used some traditional pre-processing thing. Then we are sent to the lightweighted one. The next here we are using cloud related technologies. This is a enhanced image will send. The final we are getting the enhanced output. That is the one only. Here, as I said, white balance, this kind of things, not required, these kind of things also. The next, finally, we can go for the environmental setup. Here we have data sets, as I said, like underwater image enhancement benchmark. The next, enhanced underwater visual perception. As I here, when you comes to the qualitative metrics, like the image quality metrics and also system metrics. Quality metrics, we are using these things like the peak signal to the noise ratio, the systematic metrics. See here, whenever you can go for the quantitative metrics, compare with the traditional and the deep learning and then proposed method. The proposed method you will give the better rate. Means while seeing the bar chart, then you will get the give the better performance. The next, the visual comparison. We have taken the different traditional methods. This is the final convolution method we can use. The deep learning, this is the final, the proposed method. When you compare these things, then you will get the final one as a clear and get the clarity of that image. The next, system metrics. The system metrics also we have like inference latency, the frame per rate, means frame per rate. These kind of things will give the inference latency, that is low latency. The next, here application study. Generally, traditional methods improve the stability, and also deep learning improves the image quality. The next, domain adaptation improve the robustness. The finally, hybrid model is the best. Now, our contribution, like state of the art comparison of the different traditional methods, the hybrid underwater image framework. The next, it is a lightweighted framework. The next, these are the my contribution of this one. The next, conclusion and feature work. The main, I can go for the feature work. Like so far we used image enhancement, right? In the future, you may go for like underwater video enhancement instead of image enhancement. And also you can go for the optimization, energy aware AI optimization. Then you need to focus on the fundamental kind of models. Next, to multi-model vision, that is a vision, and so on. Things we can check. That's it. The next conclusion is over. These are the references. But sorry, I given here is a reference.
Thank you so much for your insightful presentation. We can take up any questions quickly, if you have any questions.
No specific question, just a comment. This is a pretty interesting topic. Means I have seen about pollution, I've seen about this, but yeah, very good presentation and very interesting topic you picked up for your paper.
Thank you, madam. Thank you very much. Your feedback.
Okay, so now we are going to have our last presenter for the day, Dr. Sunil Dhal, who is going to present the paper titled Identification and Ranking of Barriers to Industry 5.0 Adoptions in the Indian Manufacturing Industry, a fuzzy Topsys approach under the paper ID 419. Over to you. And please adhere to the time limit. You just have 10 minutes.
Let me share my screen, ma'am.
Yeah.
Is my screen visible?
Yes.
Thank you for giving me this opportunity to present my paper on identification and ranking of barriers
to Industry 5.0 adoption in Indian manufacturing industries. Actually, nowadays, Industry 4.0 is in the current state, and we are in the transition state from Industry 4.0 to 5.0, where in Industry 4.0, we have hardcore automations where we focus on basically robotics and hardcore automations to increase the productivity. But nowadays, now industries are shifting from Industry 4.0 to 5.0. And the main core is resilience and human-centric approach. Now, instead of robots, now you will see there are a number of cobots which will work in the industry. And these are in harmony with the human. And we will focus on the presence of women in the manufacturing environment. So let me share next slide. Just a minute. Now, next slide is visible. So, Industry 5.0 focuses on transitions from automation to sustainable development, aiming systematic resilience and human-centric approach. So, I have used Fuzzy-Topsis techniques because this is a multi-criteria decision-making techniques that deal with the inconsistencies and subjectivity of the experts. So, from the literature, we identified the 12 barriers which are restricting the Indian manufacturing environment to adopt Industry 5.0. So this is the literature review. Previous studies on Industry 4.0 highlighted challenges such as high cost, lack of skills, and cybersecurity. So Industry 5.0 added additional layer involvement of adding socio-technical and ethical dimensions in the industrial systems. So Kumar and et al. Also identified the barriers of EV adoption in Indian environment. So these are the certain barriers that are identified by us in of Industry 5.0. These we have categorized all the 12 barriers into 5 major domains. So there are certain technical barriers, there are certain organizational barriers, there are certain human resources like acute shortage of trained manpower, economic aspects, social environment aspects. So these are the certain barriers. We have identified 12 barriers, and after that we categorize into 5 categories, main categories, 5 dimensions. So the aim of this, there is a research gap where the barriers are documented in isolations. There is a scarcity of research that quantify and compare the relative criticality in specific national context domain. So that's why we found the gap and we wrote this research article. So I already told you that we have categorized these 12 barriers, C1 to C12 into 12 barriers: technological, organizational, human resource, economic, and social environments. We have used Fuzzy-Topsis techniques to rank these identified barriers into their importance. So Fuzzy-Topsis is a multi-criteria decision-making techniques that select alternative distance to positive ideal solution and farthest from the negative ideal solutions. And this is also the fuzzy extension is given by Chen in 2000, integrating triangular fuzzy numbers to deal with the uncertainty in the human judgment while answering in the linguistic terms. So that data is collected from the experts which have minimum 10 year of experience, and on the position of policymakers, government perspective, and various perspectives are taken. Basically, we have taken 4 perspectives in this case, in this domain. So these are the linguistic terms used for criteria and alternative ratings. Now, Fuzzy-Topsis step 1 is construct the fuzzy decision matrix. We have constructed this fuzzy decision matrix based on the expert opinion. Again, this is the assessment, linguistic assessment for alternatives of all the 12 barriers that we have identified through the literature survey and expert opinion. After that, step 2 is determine the aggregate fuzzy weight of the criteria and alternative. Step 3 is we again normalize and fuzzy decision metrics. We are taken it into common scales. Earlier it was on 9-point scale. Now we have converted into one in a single domain on a comparable scale. After that, computing the weight, these weight are normalized in step 4. And in step 5, compute the positive ideal solutions and fuzzy topsis and negative ideal solutions. So we have identified aggregate the closeness coefficient. CCI is the CCI is the value on which we will rank these barriers. Higher the value of CCI, closeness coefficient, we will have higher will be the ranking. So result shows that this is the result where barrier 9 is the highest value of 6.06, which is high initial investment required and unclear or long-term return on those. So there is a basic gap in that. There is a lot of investment are required and return on investment is very less. Second barrier was the acute shortage of skilled workforce and advanced human-machine collaborations. So country like India is lacking in developing cobots. So they have acute shortage of that. Inadequate digital infrastructure, IoT, high-speed connectivity. Again, this is the ranked 3rd barrier. Again, this barrier 10 is again a barrier which is related to the finance, again, financial constraint and limited access to capital, especially for medium and small scale enterprises. As employment and employee and union resistance to fear of job displacement or descaling. So this is again a barrier which, because in India, like country like India, there is a lot of unions that resist the changes and technological advancement. So these are the 10 most important barriers that we have identified from the study. So primary, the ranking of barriers, fair and critical insights is country like India transition from industry 4.0 and to 5.0 presently depend on the foundational financial and capabilities, because India is a developed country and I have already told that MSME have very less financial, so they have more financial constraints. So this is the main barrier. Next one is policy of economic viability. Return on investment is very low, so it is not feasible for the industries to adopt Industry 5.0. Again, human capital. Again, we need trained manpower that can work together with the robots. Fine. So again, we have to train our manpower so that they can work with the robots. Next is your infrastructures and fundamental prerequisites. Robots basically more in MSME. Basically, they are more not. You can say IoT based. All the system are not IoT based, and again they will require thus infrastructure is inadequate, so they will require again significant physical barrier that will act as a more significant barrier because there is a lack of advanced technology in this case. Strategic leadership shortage. There is a need who can take decisions on the basis of the country, which can take hard decisions. So again, strategic leadership shortage again is a barrier. So these are the certain barriers that are identified in our research. So in conclusion, India is going to adopt 5.0, but it will take time and it will require economic skills and infrastructure constraint. If we remove those constraints, then we can adopt this Industry 5.0 as soon as possible. If policymaker and government of India focus on these issues related to financial, human resource, training of human resource, then we can implement this Industry 5.0 in a very high and very good pace. Thank you.
Thank you so much for your presentation. We can take any question if there are any. Okay, so with that, we conclude today's paper presentation session at UNI-TEAS. We sincerely thank all our presenters for their valuable contributions and our audience for their active participation. A special thanks to our session chair for guiding the discussions with clarity and depth. Now, I would like to request you all to please switch on your cameras as we take a virtual photograph to capture this memorable session. Please turn on your cameras. Um, okay. So
We
thank you
want
all.
to, yeah,
Okay,
I
okay.
can, my camera is not working. That's why I didn't open my camera.
Okay, it's okay. Thank you all, and we look forward to seeing you in the next session. Have a great day ahead.
Thank you.
Thanks, Shambhavi. Thank you.
Thank you.